Welcome aboard. For this explainer, I'm taking the helm. Consider me your tactical navigator for a pre-voyage briefing on literally one of the most infamous patches of water on Earth, the Bermuda Triangle. For decades, we've all heard the stories, right? The so-called Devil's Triangle, a cursed zone swallowing ships whole. Well, today, we're tossing the ghost stories and sci-fi myths overboard. We're going to treat this strictly as a navigational exercise, digging into the hard environmental facts and the very real physical hazards of this specific maritime sector.
Here's how we're charting our course today. First, navigating the Devil's Triangle. Then, treacherous skies and currents. Third, the threat from below. After that, a case study on Flight 19. And finally, the official Coast Guard verdict. Let's get moving.
All right, Section 1, Navigating the Devil's Triangle. So, what's truly fascinating right out of the gate is the sheer lack of an official definition. Pop culture loosely bounds this region between Florida, Bermuda, and Puerto Rico, but from a cartographical standpoint, it essentially doesn't exist. There is no universally agreed-upon boundary. In fact, the U.S. Board of Geographic Names absolutely does not recognize it, nor do they even keep a file on it. It's a region born completely of Hollywood and pop culture, not official maritime charting.
And because of that, there's just this massive divide between the pop culture myth and maritime reality. On one side, you've got time warps, alien abductions, and supernatural forces. But listen, when captains and pilots actually train for operations in this sector, they are definitely not training for aliens. They prepare for severe, rapidly shifting weather. They prep for inevitable equipment failure, the incredibly complex underwater topography of the Caribbean, and honestly, the biggest factor of all, human error. Inexperienced or disoriented navigation in a high-traffic area like this, that's the real danger.
Moving on to Section 2, Treacherous Skies and Currents.
Okay. Here's what sailors are actually up against out there. It's a literal hotbed for unpredictable weather and sudden, violent storms. Cutting right through the heart of it is the Gulf Stream. Think of it as a massive, hyper-powered underwater river that can rapidly change the weather and sweep wreckage miles away from a disaster site in a matter of hours. Then you've got disorienting rogue waves, these terrifying sudden walls of water. Add to that a minefield of treacherous shallow waters around the Caribbean islands, and finally, compass variations. In this specific area, a magnetic compass can sometimes point to true north instead of magnetic north. If a navigator doesn't catch that, it can throw a vessel miles off course.
This whole reality is captured perfectly by NOAA's National Ocean Service. Quote, "The ocean has always been a mysterious place to humans. When foul weather or poor navigation is involved, it can be a very deadly place. We absolutely must respect the sea. The ocean doesn't need supernatural forces to be lethal, you know? Poor weather combined with bad navigation is a deadly combination literally anywhere on Earth. This particular region just happens to be one of the most heavily trafficked on the planet."
Which brings us to Section 3, the threat from below.
Now, let's talk geology. What we're looking at here are methane clathrates, or as it's sometimes called, fire ice. It's basically this cage-like structure of water molecules that traps methane gas inside, forming as a naturally occurring solid deep down on the seafloor where the pressure is immense and the temperatures are freezing. And the Bermuda Triangle region sits on massive deposits of these hydrates. To put the scale into perspective, these deposits globally contain twice as much carbon as all known coal, oil, and conventional natural gas combined. It's a staggering amount of energy just sitting right there.
So, how does fire ice become a deadly hazard? Well, if these deep-sea deposits rupture, say from an underwater landslide, it triggers a massive methane eruption. Basically, a giant slug of gas is violently released into the water column, turning the ocean surface into a frothy, gas-saturated mess. And here is the terrifying physics of it all. This drastically reduces the water's density and buoyancy. If a ship happens to sail into this frothy water, the ocean literally can't support its weight anymore. The vessel just drops. It sinks rapidly, without warning. And if that wasn't crazy enough, if the eruption is big enough, the gas released into the air can actually choke the aspirated engines of aircraft flying directly overhead.
Now, if you're thinking this sounds like some theoretical sci-fi scenario, I promise you it's not. Scientists have actually found huge craters off the coast of Norway, some measuring a half-mile wide and 150 feet deep. These were formed by massive, destructive underwater methane blowouts.
It's a proven, immensely powerful natural phenomenon, and frankly, it perfectly explains how a vessel could just vanish without a trace or even time to send a distress signal.
Let's look at a real-world example in Section 4, Case Study, Flight 19.
This is arguably the most famous disappearance in the region, so let's strip away the sensationalism and look at the actual tactical assets. On the left, you've got the 5 TBM Avengers of Flight 19. 14 men took off on what was totally supposed to be a routine navigation training flight. On the right is the massive PBM Mariner search aircraft. When Flight 19 got disoriented, this Mariner, with a crew of 13, was sent out to find them. Tragically, as you probably know, all 27 men and all 6 aircraft vanished.
So what exactly went wrong? Let's break down the tactical timeline from December 5, 1945. They took off at 14:10 in totally fine conditions. But fast forward to 1540 and the flight's instructor reports a catastrophic mechanical failure. Both of his compasses are down. By 1600, the crew is dealing with complete disorientation over the Florida Keys. The instructor mistakenly orders the flight north and east, pushing them further out into the open Atlantic, away from any land. Meanwhile, the weather is rapidly deteriorating into turbulent seas and high winds. They flew until they quite literally ran out of fuel and had to ditch in rough, pitch-black waters. At 1820, that PBM Mariner deploys for the rescue. Now, those Mariners had a known reputation for fuel vapor leaks. A nearby ship actually reported seeing a mid-air explosion at the exact coordinates the search plane was supposed to be. A massive 200,000 square miles search yielded absolutely zero wreckage. It's a tragedy for sure, but the cascading failures were grounded in mechanical breakdown, complete disorientation, and an unforgiving ocean, not the supernatural.
And that brings us to Section 5, the official Coast Guard verdict. When we consult the ultimate authority on marine safety, the United States Coast Guard, they are completely unequivocal about this. They explicitly state the Coast Guard does not recognize the existence of the so-called Bermuda Triangle. No extraordinary factors have ever been identified. They've reviewed countless aircraft and vessel losses over the years, and they found absolutely nothing to indicate casualties were caused by anything other than physical causes. The official, definitive verdict, the blame falls squarely on harsh environmental factors and human fallibility.
Which really leaves us with this final provocative thought. We've seen the hard evidence today. We know the raw power of the Gulf Stream, the blinding speed of severe storms, the terrifying potential of methane blowouts, and the tragic domino effects of a broken compass and human panic. So knowing the sheer indifferent power of the sea and the very real limits of human navigation, why do we still prefer a supernatural myth over the sobering reality of nature? Honestly, maybe it's because blaming a cursed triangle is just easier than admitting how small and vulnerable we truly are when facing the vast, unforgiving power of the open ocean. Thanks for joining me for this briefing on The Explainer today. Stay curious, stay informed, and always respect the sea.